You look at the old computer keyboard sitting in your garage. The keys that used to be white are now the color of old newspaper. Sick, yellowed, disgusting. You've tried bleach. You've tried hydrogen peroxide in the sun. You've tried every product the internet swears will work. Nothing happens. The yellow stays. But there's a technique that Soviet factory workers used for decades. A method so simple it sounds like a joke. 30 seconds of rubbing with a 15-cent sponge and a drop of cooking oil. No chemicals, no waiting, no UV lamps. The yellow vanishes like it was never there. Today, we're exposing the mechanical cleaning method that the plastics industry doesn't want you to know, because if this gets out, they can't sell you replacement parts anymore. Stay until the end, because what you learn here will save you hundreds of dollars and countless hours of frustration. Let's start with why plastic turns yellow in the first place. Most people think it's dirt or staining. It's not. It's a chemical breakdown happening inside the polymer itself. The plastics used in electronics, light switches, window frames, and appliances from the 70s, 80s, and 90s contain a flame retardant called bromine. When ultraviolet light hits this plastic, it triggers a reaction. The bromine compounds migrate to the surface and oxidize. That oxidation is what you see as yellow or brown discoloration. It's not on the plastic. It's in the top molecular layer of the plastic. This is why surface cleaning doesn't work. You're not dealing with a stain. You're dealing with chemically altered polymer chains. Bleach can't reverse this. Soap can't remove it. The oxidized layer is physically part of the material now. The only way to eliminate the yellowing is to remove that damaged layer entirely, or to change how light interacts with it. This is where the Soviet method comes in, and it works on a principle that modern cleaning product companies will never tell you about. In Soviet manufacturing plants during the 1970s and 80s, plastic components were everywhere. Computer housings, instrument panels, laboratory equipment, telecommunications devices. All of it made from ABS, plastic, or polystyrene with bromine flame retardants. And all of it turned yellow under fluorescent factory lighting and natural UV exposure. But Soviet factories couldn't just throw away expensive equipment and buy new housings. The economy didn't work that way. There was no Amazon Prime delivering replacement parts. Engineers had to maintain what they had. So they developed a two-step restoration process that cost almost nothing and worked perfectly every time. The first step was mechanical removal of the oxidized layer. They used a very specific type of abrasive material, not sandpaper, which is too aggressive and leaves visible scratches, not steel wool, which embeds metal particles into the plastic. They used melamine foam. You know it today as a magic eraser or generic melamine sponge. But the Soviets were using this material in industrial applications decades before it became a consumer cleaning product in the West. Melamine foam has a unique structure. Under a microscope, it looks like a three-dimensional net made of extremely hard, thin fibers. When you rub it against plastic, these fibers act like microscopic chisels. They shave off the oxidized surface layer molecule by molecule. The foam is hard enough to remove damaged polymer, but soft enough not to gouge the underlying material. It's the perfect hardness for the job. The technique is absurdly simple. You wet the melamine sponge with plain water. Not soapy water. Not chemical solutions, just water. The water lubricates the abrasive action and carries away the removed material. Then you rub the yellowed plastic in circular motions with moderate pressure, not hard enough to bend the plastic, but firm enough that you feel resistance. Within 10 to 20 seconds, you'll see the sponge turning yellow or brown. That discoloration on the sponge is the oxidized layer being mechanically stripped away. You're watching the damage literally come off the surface. Rinse the sponge. Repeat if necessary. For light yellowing, one pass is enough. For severe cases, you might need 2 or 3 passes. But the total time is still under a minute per square foot of plastic. The speed is shocking if you've never seen it before. You spend weeks researching chemical treatments and UV exposure methods, and then a damp sponge solves the problem in 30 seconds. But here's where most people stop and where they make a critical mistake. If you leave the plastic after the melamine treatment, it looks better. The yellow is gone. But the surface is now microscopically rough. You've removed the oxidized layer, but you've also removed the smooth factory finish. Under direct light, the plastic looks slightly hazy or matte instead of glossy. This is where step 2 comes in. The Soviets knew that the mechanical cleaning needed a finishing treatment. They used oil. The oil step is counterintuitive. You just cleaned the plastic. Why would you put oil on it? Because oil fills the microscopic scratches left by the melamine abrasive. Plastic is a polymer, and oil is a hydrocarbon. They have compatible chemistry. When you apply a thin layer of vegetable oil to the cleaned plastic, capillary action pulls the oil into every tiny groove and pit in the surface. The oil has a refractive index very close to the plastic itself. This means light passes through the oil-filled scratches as if they weren't there. The surface regains its optical smoothness. It looks glossy and new again. The Soviets used sunflower oil because that's what was available in Soviet supply chains. But any light vegetable oil works. Canola, corn, soybean, whatever is in your kitchen. You put a few drops on a clean cloth and wipe it across the plastic in even strokes. Let it sit for 60 seconds so the oil can penetrate fully. Then buff off the excess with a dry cloth. What you're left with is plastic that looks factory fresh. The yellow is gone, the gloss is restored. And the total cost is about 15 cents worth of melamine sponge and a nickel's worth of oil. 20 cents to restore something that manufacturers want you to replace for $20 or $200. Have you ever tried cleaning yellowed plastic with a magic eraser? Write your answer in the comments. Now let's talk about why this method disappeared from common knowledge in the West. When the Soviet Union collapsed in 1991, a lot of industrial practices and techniques were lost in the chaos. Factories closed, engineers retired or emigrated. The institutional knowledge that kept Soviet industry running just evaporated. Meanwhile, in the United States and Western Europe, the consumer economy was booming. Why fix a yellowed computer case when you can buy a new computer every 2 years? Why restore a light switch when replacements cost $3? The economic incentive to maintain and repair was gone. Companies realized they made more money selling replacements than selling cleaning methods. A plastic restoration technique is a one-time purchase. You learn it once and use it forever. But replacement parts are recurring revenue. Every yellowed component is an opportunity for another sale. The business model of planned obsolescence depends on people not knowing how to fix things. It depends on creating a culture where restoration seems harder than replacement. And for 40 years, that's exactly what happened. The knowledge existed, but it wasn't profitable to share it. The melamine foam itself has an interesting history. It was developed in the 1960s by BASF in Germany as an insulation material. The rigid foam structure made it an excellent thermal and acoustic insulator. But someone discovered by accident that it also worked as an abrasive cleaner. The German chemical industry patented various formulations, but they positioned it as an industrial cleaning product, not a consumer item. Soviet engineers got their hands on the material through trade relationships with East Germany. They immediately saw applications beyond insulation. By the late 1970s, Soviet technical manuals for electronics maintenance included melamine foam treatment as a standard procedure for plastic restoration. This wasn't a secret. It was documented in maintenance protocols and taught to technicians. But those manuals were in Russian, filed in factory archives, and never translated or distributed in the West. When melamine sponges finally hit the American consumer market in the early 2000s under the Mr. Clean Magic Eraser brand, they were marketed as a general cleaning product. The advertising focused on removing crayon marks and scuff marks from walls. Nobody mentioned that it could reverse polymer oxidation. Nobody explained the chemistry of why it worked on plastics. And absolutely nobody combined it with the oil finishing step. The product was sanitized for consumer use, stripped of its most powerful application. If you're getting value from this, Hit subscribe and drop a like so this doesn't get buried by the algorithm. Let's dig into the actual chemistry of what's happening during this restoration process, because understanding it will help you apply the technique correctly. When bromine-containing plastic oxidizes, the bromine atoms bond with oxygen from the air. This creates brominated organic compounds on the surface. These compounds absorb blue light wavelengths preferentially, which is why the plastic appears yellow. Yellow is what's left when you subtract blue from white light. The melamine foam physically removes these brominated compounds. Each pass of the sponge strips away a few micrometers of damaged material. You're not cleaning the yellow off, you're removing the layer that contains the yellow. This is critical to understand because it means the technique works on any yellowed, bromine-containing plastic, regardless of how old it is or how severe the discoloration. You're not relying on a chemical reaction. You're using mechanical abrasion. The oil step then addresses the light scattering problem. When you abrade plastic, even with a fine abrasive, you create surface roughness. This roughness scatters incoming light in random directions. That scattering makes the plastic look dull or cloudy. Oil smooths the optical path. Light hits the oiled surface, passes through the oil layer without scattering, enters the plastic, and reflects back cleanly. The surface appears glossy and transparent again. This is the same principle behind why a scratched car finish looks better after waxing. The wax fills the scratches and restores the optical smoothness. There's a secondary benefit to the oil treatment that the Soviets absolutely understood, but that modern cleaning products ignore. Oil creates a protective barrier. After you've removed the oxidized layer, the fresh plastic underneath is vulnerable to new oxidation. UV light will start attacking it immediately. But a thin oil film blocks some of that UV penetration. It also prevents oxygen from reaching the polymer surface. This slows down the re-yellowing process dramatically. Soviet technicians would re-oil plastic components every 6 months as preventive maintenance. The plastic in their factories stayed white for decades, while identical equipment in Western facilities yellowed and was thrown away. This wasn't because Soviet plastic was better, it was because Soviet maintenance practices were better. They understood that plastic needed care and protection, not just cleaning. Now here's where it gets really interesting. The plastics industry knows about this technique. They have research chemists who understand polymer degradation, but they have zero incentive to tell consumers about mechanical restoration. The global plastic manufacturing industry generates over $500 billion annually. A significant portion is replacement parts for items that still function but look bad. Yellowed computer cases, discolored appliances. If everyone knew they could restore these for 20 cents instead of buying replacements, that's billions in lost revenue. The industry benefits from yellowing. It's built-in obsolescence. The product works, but looks so bad that consumers replace it out of shame. This drives sales without requiring actual failure. There's also the aftermarket restoration products issue. Auto parts stores have shelves full of plastic restoration chemicals costing $10 to $30 per bottle. They work by depositing a temporary coating that hides yellowing, but the coating wears off in weeks. Then you buy more product. It's the subscription model applied to plastic care. The melamine and oil method doesn't wear off because you've removed the damage and protected the surface. No repeat purchase, no subscription. From a corporate standpoint, this is a nightmare. A permanent solution that costs almost nothing cannot be monetized. Let me show you exactly how to do this on the most common yellowed items people deal with. Start with old computers and electronics, keyboards, mice, computer cases from the 80s and 90s. These almost always have severe yellowing because they were made with high bromine ABS plastic and exposed to constant UV from indoor lighting. Disassemble the item if possible to access all surfaces. Get the plastic wet with plain water. Take your melamine sponge and rub in small circular motions. You'll see the yellow transferring to the sponge immediately. For textured surfaces like keyboard keys, use light pressure and let the sponge conform to the texture. For smooth surfaces like case panels, you can use firmer pressure. Work in sections about 6 inches square. Rinse the sponge frequently as it loads up with removed oxidation. When the plastic looks white again, dry it completely. Then apply your oil. A few drops on a microfiber cloth, wipe it across the surface. Let it sit briefly. Buff off the excess. The transformation is dramatic. Plastic that looked like it spent 40 years in a smoker's house comes out looking factory new. For light switches and electrical outlets, the process is the same, but requires care. Turn off power at the breaker if working on installed switches. Remove cover plates if possible. If cleaning installed components, keep the sponge just damp, not dripping. Work quickly and dry thoroughly before restoring power. The oil step provides additional insulation and prevents dust accumulation. Window frames and vinyl siding present a larger surface area challenge. Get melamine sponges in bulk for about 10 cents each. For window frames, work section by section. Wet, scrub, rinse, dry, oil, buff. You can do an entire window in 10 minutes. For a whole house, budget an afternoon. The visual impact is incredible. Yellowed vinyl that made your house look neglected suddenly looks maintained. Neighbors will ask if you replaced your windows. You spent less than $10. Old appliances are another great application. Refrigerators, washing machines, and dishwashers from the 70s and 80s often have yellowed plastic trim and handles. These appliances were built to last forever mechanically, but the aesthetics aged badly. You can restore them completely. The handles especially benefit because people touch them constantly. The oil finish feels smooth instead of rough and oxidized. Here's a professional tip. Temperature matters. If working on very hard, brittle plastic, warming it slightly makes the melamine treatment more effective. Not hot, just slightly warm. Leave the plastic in sunlight for 15 minutes or use a hairdryer on low. Warm plastic is slightly softer, and the abrasive action works faster. Cold plastic, especially in winter, is more brittle and resistant. You'll need more passes and firmer pressure. The restoration longevity depends on UV exposure after treatment. Plastic kept indoors out of direct sunlight can stay white for years. Plastic in direct sun or under UV lighting will yellow again within months. The oil layer provides some protection, but it's not permanent. For outdoor applications, reapply oil every few months. This is still cheaper and easier than replacement, but it's not one-time permanent. You're reversing existing damage, not making plastic immune to future damage. Common mistakes people make: using too much pressure or working too aggressively. Remember, you're removing material. If you abrade too deeply, you'll create visible scratches or thin the plastic. Light to moderate pressure is sufficient. Let the foam do the work. Another mistake is skipping the oil step or using the wrong type. Motor oil is too thick and leaves greasy residue. Petroleum products can damage some plastics chemically. Stick with food-grade vegetable oils. A third mistake is not testing on an inconspicuous area first. Some plastics have thin walls. Aggressive cleaning could wear through. Always test on a hidden spot. There's a related technique for clear yellowed plastic worth mentioning. Old eyeglasses, acrylic display cases, or transparent computer panels can't be treated with melamine because surface abrasion makes them cloudy. For these, Soviets used progressive polishing. Start with cutting compound to remove oxidation, then move to finer polish until you achieve optical clarity. The oil step still applies, but this requires more skill and time. Still cheaper than replacement, but more involved. Now let's talk about the environmental angle. Every yellowed piece of plastic thrown away and replaced contributes to landfill waste. Most is still structurally sound, discarded purely for aesthetics. If restoration knowledge were common, millions of pounds of functional plastic could stay in service. The environmental impact of manufacturing new plastic is enormous. Petroleum extraction, energy-intensive polymerization, transportation, packaging, all for a replacement that's functionally identical to what's being thrown away. The old Soviet maintenance culture, born from economic necessity, was more environmentally sustainable than modern Western replacement culture. The technique works on automotive plastics with caveats. Car interiors from the 80s and 90s often have yellowed plastic trim, dashboard components, and door panels. However, automotive plastics are often treated with UV stabilizers and protective coatings. The melamine will remove these along with oxidation. You need to be extra careful with the oil step and consider applying automotive plastic protectant afterward. The oil alone might not provide enough UV protection for parts seeing direct sunlight through windows. Still cheaper than replacing interior trim panels, which can cost hundreds. For extremely stubborn yellowing that doesn't respond to melamine alone, there's an advanced version. After initial melamine treatment, some technicians use very fine polishing compound. This removes even more oxidized layer, but requires careful technique to avoid haze. After polishing, the oil step becomes critical because you've created a smooth but vulnerable surface. This was reserved for high-value components like precision instrument housings. For most household applications, basic melamine and oil is sufficient. There's something satisfying about watching restoration happen in real time. When you rub that sponge and see yellow coming off, you're witnessing material science in action. You're seeing oxidized polymer being mechanically removed. Chemical treatments don't give you this. You apply them and wait hours or days. The uncertainty is frustrating. With the mechanical method, you know within seconds if it's working. This immediacy is why Soviet technicians preferred it. In a busy factory, you can't wait days. You need results now. Let me give you the exact process one more time, refined from decades of Soviet experience. Assess the yellowing. Determine if it's surface oxidation or if there's dirt mixed in. If there's dirt, clean it normally first. Wet a melamine sponge with plain water. Squeeze out excess so it's damp, not dripping. Rub the yellowed plastic in circular motions with moderate, even pressure. Work in sections about 6 inches square. Rinse the sponge frequently. You'll see it turning yellow as it picks up oxidized material. When the plastic looks white and uniform, stop. Overworking risks visible scratches. Dry the plastic completely with a clean cloth. Apply 3 to 5 drops of vegetable oil to a microfiber cloth. Wipe the oil across the cleaned plastic in even strokes. Cover the entire treated area. Let the oil sit for 60 to 90 seconds. This allows capillary action to pull oil into the surface texture. Buff off excess oil with a clean, dry cloth. Use circular motions and light pressure. The surface should feel slightly slick, but not greasy. Inspect under good lighting. The plastic should look glossy and uniform. For ongoing maintenance, reapply thin oil layer every 3 to 6 months, especially for items exposed to UV. The total time for a typical item, like a keyboard or light switch plate, is under 5 minutes. Materials cost under 25 cents. Compare this to buying a replacement keyboard for $30 or new light switch for $5. The savings add up instantly. But more importantly, you've preserved something functional. You've prevented waste. You've applied knowledge deliberately hidden for profit reasons. One last point about the political economy of this knowledge. The Soviet system, for all its flaws, created a maintenance culture out of necessity. Resources were scarce. Replacement parts were difficult to obtain. Engineers had to make things last. This produced practical solutions like the melamine and oil restoration. Meanwhile, in the capitalist West, abundance created throwaway culture. Why fix when you can replace cheaply? But that abundance was an illusion built on cheap energy and exploited labor. As resources become more expensive and environmental costs undeniable, maintenance culture starts making economic sense again. The techniques Soviet workers used aren't just historical curiosities. They're practical solutions to current problems. The melamine foam and oil method isn't magic. It's applied materials science. It works because it addresses the actual physical problem rather than trying to hide it chemically. The oxidized layer gets removed mechanically. The surface texture gets restored optically. The underlying plastic gets protected from future damage. Each step has clear purpose based on how polymers behave. This is engineering, not marketing. That's why it works when expensive products fail. Products are designed to be sold. Engineering solutions are designed to solve problems. In this case, the engineering solution won, but only if you know it exists. Have you ever tried cleaning yellowed plastic with a magic eraser? Write your answer in the comments. And if this video just saved you from throwing away something that still works, hit subscribe. The industry has hidden more than just this from you. We're just getting started.